students, welcome back to 2D video game design. Today we are going to add a patrolling enemy into our game. So just like we've done before, I'm just going to right click and create a new 2D object that's a sprite. And I'm going to call this one Green Enemy. And the reason I called it Green Enemy is because I've already gone and made a sprite for it with a little 2-frame animation. It kind of looks like a green turnip, I think, but I'm just gonna add this one sprite to it. Hang on, I think I'm in the wrong spot. Green Enemy, there we go. There we are. Now, of course, we don't want him to be that huge, so let's scale it down. And then let's go ahead and move it so it's on top of this platform. Do some basic stuff here. Let's go ahead and give it a rigid body. There's my rigid body 2D. And let's go ahead and give it a box collider 2D. And let's go ahead and make a script for it. So I would like to create a patrolling effect for this guy. So let's go ahead and make a C# script. I'm going to call this a patrolling enemy. Okay, so we'll just do some basic stuff first. Let's just make this guy move to the right. So I'm going to start off by giving a public float speed, and we'll just say right now the enemy speed is 2, and just do a real basic move forward transform.translate. And we want this enemy to move vector2.right times time.delta time delta time times speed. Okay, let's hit Control S and then go back to Unity and wait for that to compile. Just a quick second. Okay, and now I'm going to take the patrolling enemy script and move it onto my green enemy. And now I should get some enemy movement here. Okay, had a little glitch there. What ended up happening was the Z value of my sprite was not at 0, so I couldn't see the enemy on my screen. But now I can see. I'll push play and off you go. Okay, so as this character fell off, they tilted forwards a little bit, and that's okay. We can fix that pretty easily by freezing the rotation on the Z axis. And now we get this type of movement. Now that's a little bit fast, so I'm gonna go into the patrolling enemy and I'm gonna cut that speed in half. There we go. So the next thing that I want to do is make it so that this character here can patrol by going forward, getting up to the edge, and as soon as they get to the edge, I want them to turn around and go the opposite direction. That way they can do a patrol on this platform right here. So in order to do that, we're going to do something called raycasting. Raycasting is going to shoot a laser, an invisible laser, from a specific spot and then tell me some information about anything that it hits. So what I'm gonna do here is I'm going to create an empty object here for the laser to shoot out of. So we're just going to create an empty game object. And one of the things, I haven't done this very much, is I can put an icon on this. So I'm just going to put a red icon on there just to remind me where this is. And I'm going to move it just right in front of this guy. Okay, it's a little bit above the ground. And this is going to be my ground detector. So let's make this the ground detector. And then once I have the ground detector, I'm going to parent it to the green enemy. Okay, so now these two are attached. So let's jump into the script. Oops. Okay, so I want to be able to access the ground detector. So I'm going to say that I have a public transform called ground detector. And in order to get that, I need to get the transform of the child to my object. So I'm going to say at the start, ground detector is equal to game object dot transform. So now keep in mind, right now we're on the enemy, so I'm saying the green enemy has a transform, and now within that transform I want to find the ground detector. So that is with the find command, and I want to find the ground detector. And so now that's going to give me a game object, and within that game object I want to grab its transform. Okay, now that works. That's going to give me the ability to actually find the ground detector game object. At this point, I feel like it's worth the time to go and investigate how Raycast 2D works. So here's the thing, we're going to have something called a Raycast. Raycast is a part of the Physics 2D library. So in order to do a Raycast, we would do physics2d.raycast, and then within Raycast we would have some arguments. We would have the origin, and then origin, and then the direction, and then optional, you can also put the length of the ray. So if you don't put a length right there, it's going to assume that you want it to keep on going until it hits something. We can do a length to make it so that our Raycast has a range. Now, after it does this, it is going to return an object called a Raycast hit 2D. And this is the object that is going to have all of the information on it that we're going to use to figure out anything that we need. So specifically, we're going to have something called the collide. On the Raycast hit 2D object, the collide is information about the collision that has happened. So, all that being said, let's go back into our code. So what we want right here is to say that we're going to get into the Physics 2D library, and then we are going to Raycast. And I want that Raycast to start from the ground detector object. So ground detector, and remember that's the transform of the ground detector, so already I can just say position. So I want to fire a laser from the ground detector. Next one is the direction that it's going. So I want it to shoot vector2.down. And now the next thing is how far down should it go? I don't want it to go down forever, because if my character is 10 feet off the ground, I don't want it to think that it is on the ground. So let's go ahead and just say that this is 1F. Now, all of this is well and good, and you can see there's no errors in here. However, like I mentioned, all of this is going to return a raycast hit. And so all of this is happening, the laser's getting fired, it's hitting something or not, but I need to save that information. So I'm going to say I have a variable that is of type raycast hit. So let me give some space here. Raycast hit 2D. And I'm going to call this one ground ray. Okay, and of course with variables you can name them whatever you want, but this is the actual ray that's being fired out. Now the next thing I want to do is while it's on the ground in front of it should exist, and so it should collide with the box collider of the platform. So I'm going to say if ground ray dot collide, and this is the collider that has been hit by the ground ray. And remember right here, the distance on it is only 1, so it's not going real far. So if ground ray dot collide does not equal null. So that means if it hit anything at all, equal null. So that means that it hit nothing. If ground ray dot collide is null, oops, sorry, not collide, collider. If ground ray dot collider is null, that means it didn't hit anything, then our character should flip directions. So transform dot translate, not translate, transform dot rotate. And then if you remember, within rotate we have 3 values: the rotation on the x-axis, the y-axis, and the z-axis. And in this case we kind of have to think in 3 dimensions here, because what we want to have happen is we want it to rotate 180 degrees on the y-axis. So 0 on the x-axis, 180 degrees on the y-axis, and then 0 degrees on the x-axis. I'm going to put S in front of these just to make them floats. Control S to save it. Then let's see how that works. There we go. We've got some nice rotation there. He's going back and forth at a regular speed. And then I can go over here and he's pushing me off of the... Oh no! Okay, so let's go ahead and add in some more functionality to this enemy. So I've done a little bit of stuff in the background, stuff that we've done before, so I just want to show you some changes that I've made. So now I've got my enemy that goes back and forth, and if I come into contact with it, I get knocked back, and I do a hurt animation. So these are all skills that we've done in the past, but I do want to show you what the code looks like. So let me jump onto the player controller. So when I get hurt, I've got a couple of variables. I've got the hurt time, which is the amount of time that I stay hurt. I've got a bool is hurt that is false right now. And then I've got a knockback force. So, I also added on here right before the move command, the translate, that this only executes if is hurt is false. So now I've got the hurt time delay, and this is a quick coroutine that we've done before, but it's going to wait for hurt time seconds, and after that time it's going to turn is hurt to false. It's also going to talk to the animator. Now I made another method called hurt that says sets is hurt to true, then communicates to the animator that is hurt is true, and then it adds force to the rigid body to the left and upwards. And we do that by adding the two vectors. It's an impulse force. And then it starts the coroutine hurt delay, which is right up here. Now the patrolling enemy on collision, if it's colliding with the player, then the collision has a game object, and that game object has a component called the player controller, and that player controller has a method called hurt, and we're going to run that. And that is how we get this effect. Now what I want is to have a Mario Brothers type effect where I can jump on top of the enemy's head and defeat this enemy. But right now, no matter how I hit this enemy, it's always going to hurt me. So let's make that change. So the first thing that I want to do is edit the enemy here to make it so I can detect whether the enemy was struck from the side or from the top. Now this collider right here, I can consider this to be the side. So I'm just going to edit this and I'm going to shrink that down right there. And then I'm going to add an empty game object, and I'm going to call this head detector. And then I'm going to move that up here, and let's go ahead and add a box collider 2D to it. We can shrink this down about that big. And then let's go ahead and parent it to the enemy. And now I can see that I've got this smaller collider on top of the big collider. And let's go ahead and shrink that down a little bit more. And then I'm just going to move it so it's a little bit more centered. Like that. And there we go. I've got the head collider parented to the enemy. Just going to make one more little adjustment. It is a little bit above the head right there. Now, what I want to do is I'm going to end up writing a script for the head detector, but I'm going to go into the patrolling enemy and I'm going to create a new variable. This is going to be a private bool head collision, and right now it is false. We have not had a head collision. So if I have this collision here, if the collision is the player, I want it to run the hurt method. But I only want to run that hurt method if I am not having a head collision, if I'm having a side collision. So if it is the player, I'm going to say if not head collision. Adjustment here real quick. There we go. I'm going to Control S to save that. So now this will only happen if it collides with the player and it has not had a head collision. Now let's go back here. So right here, I'll create a C# script. Head detector script. Now the head detector script is going to be very simple because all I need it to do is to tell the main enemy that it's been hit on the head. So let's name a variable. I'm going to have a private game object called parent. And that's going to be the big enemy. So in the start method, let's go ahead and find it. Parent is equal to game object dot transform dot parent. Easy enough. There we go. Dot game object. Okay, now in here, oops. Let's make a public void on collision enter 2D. And again, we want to check to see if this is the player. If collision.gameObject.compareTag is the player. Then we need to let the parent know that it's been hit. So parent dot get component. That this would be the name of the script here, so that would be the patrolling enemy. Dot head collision. Oops, you know what? I'm gonna go over here to patrolling enemy, and I accidentally made this private, but I need to access it from somewhere else, so I'm going to make that public real quick. Then when I come back here, head collision is equal to true. Okay, Control S to save that. So now, if the player hits the head, head collision will be true. So now let's go back to the patrolling enemy and say, if head collision is false, then run the hurt method. Else, so that means head collision is true, we'll just do game object. Oh, we want to destroy the game object. Destroy game object. Control S to save. So now I'm going to make sure that I go ahead and take the head detection script and actually attach it to my head detector. Now, oh, why are you falling off of there? Okay, so if I jump on the enemy's head now, I'm able to defeat the enemy. Okay, so now that I've got my green enemy working, I can go into prefabs and, oh, I did this earlier, so I'm gonna delete that guy. And I have this guy set up the way that I want, so I'm gonna take this green enemy and I'm gonna move it into the prefab. And then I can go ahead and start designing my level. There, put a guy here, and a guy here. Let's see how that looks. Okay, he's off. Gets bonked by the platform, and then, oh, hurting animation is okay, but I'm gonna bonk him. He's dead. Okay, and then we've got these guys patrolling around here. Oh, and looks like I got hurt there. And And I've got this guy here. Boom.